So in this case, x bar is equal to the summation of f of x over the summation of f. We already know we are finding the mean here. So f summation of f of x is 82. That is here already, we don't need. Over the summation of f, which is 35. And then that will give us to 3 sig fig 2.34. Then we need to find the mode. Now, in this case, the mode you notice is 2. And I told you in the case of ungroup data, the mode is the value that corresponds to the highest frequency. So if we look at the frequency column, what is the greatest number in this column here?
12.
12. So the number that corresponds to the greatest frequency, which is 2, will be the mode. And that is quite logical because remember, if you would have listed the amount of tools, you need to have listed 2 12 times. 2, 2, 2, 2, 2, 2. This is telling you there are 12 tools. This is telling you they have 9 trees and so on. So in this case, the median, I told you that n is the summation of f of f. So in that case, the summation of f is 35 plus 1. That will be half of 36. That's the 18th value. Now, here is where the cumulative frequency comes in. The 18th value. So we go to the cumulative frequency. If you notice, the 18th value doesn't fall in the 3 here, it doesn't fall in the 8, but it falls in the 20. The 18th value falls in the 20 here. And the value that corresponds to that is 2 as well. Then we do the same for the lower quartile, which is 1/4 of 36, which is the 9th value. So we go back here. Once again, the 9th value will fall into this 20. Everybody agree? So that will be 2 as well. Then for the upper quartile, 3/4 of 36 is the 27th value. So we go back here to the cumulative frequency. The 27th value falls inside the 29, the 27th value. So the value that corresponds to that is 3. So which means then that the upper quartile is 3. Then from there, we find interquartile range, which is the difference between the upper and the lower quartile. So we're going to have that Q3 was 3 that we found, Q1 was 2. So the interquartile range is 1. The semi-interquartile range will be half of the interquartile range, which is half of 1, which will give us 0.5. And then to find the standard deviation, we have the formula, which is the summation of f of x squared, which we have found in the table. We have the summation of f, and we have the mean. Remember, we have calculated the summation of f of x squared, which was 248. But in this case, I think we change the value, right? No, yeah, 248. This one, I was thinking about the other one. So that will be 248. You see, the 248 is this one here. Summation of f of x squared over the summation of f, which is 35, and then the mean is 2.34. So we go here and we substitute for the standard deviation. That when we simplify, we get 1.27. Now I will give you 1 minute, exactly 1 minute, for you to plug this into your calculator and see if you get 1.27 to 3 sig fig, which means then that you are using your calculator correctly. If not, then you have to try and try until you get that value.
Yes, I get 1.26, but once you round it out to the
Yes, so yes, you get 1.26 and a number that is greater than 5 behind it. So when we round it off to 3 sig fig, then it is 1.27.
yes, sir.
Okay. Everybody satisfied with that?
Yes, sir.
Okay, good. Now, remember, if we look at if you go to our distribution, which is 100%, and we were to plot a cumulative or an O-graph curve, which will give a cumulative frequency curve. If we take 25% of the distribution, that would have been 25 over 100, which gives you this 1/4. Which is quarter way of the distribution. Then the median, which is Q2, the median is before that. The median, which is Q2, is the central value or midway of the distribution. So that would be 50%, which is a half of 100. So it's gonna be 50 over 100, you get a half. These values are one that are exact. Then here for Q3 is the same thing. It's 75% of the distribution which give us Q4. Now, what will happen to those values between 0 and 25, the percentages between, let's say, 1 and 25, between 1 and 25, and 1 inclusive, so between 0 and 25, exclusive, right? So, and then what will happen to the values between 25 and 50? Like 30%, 35 of the distribution. And what will happen between 50 and 75, and then 75 and 100? There are other percentages that are there. These one only wrap up the distribution that is a quarter, half, and 3/4 of the distribution. Now, I'll be showing you how we find the trim mean as well as the percentile of a given set of data. So first of all, I will begin with the trim mean when it comes to raw data, how we find the trim mean for raw data. Okay. First of all, you need to know what is trimmed mean. When you go to a barber and when they trim you, what are they doing?
Cutting.
They are cutting. So when they are cutting the hair, what are they actually doing with the hair?
Moving the hair that's in excess.
Removing the hair, right? We remove. So whenever you go and get a trim, you remove certain length of hair to your desire that you like, and then you leave it there. So trimmed meaning then that you will notice here that we will be cutting off some values from a set of observation. First, we're gonna be looking at raw data, and then from there, we're gonna be looking at also on group data. What is the purpose of a trim mean? The mean that we were finding first, the other means, is known as the actual mean or the arithmetic mean, the actual or the arithmetic mean. Now, I use this notation here has been used to represent a trim mean. Mean sub t, meaning this is a trim mean. And usually a percentage will be given to you to trim off. Now, why you would be wondering why is it that statisticians, those are the ones that carry out survey, that the statisticians actually brought in this term to mean. As human, whenever we do research or we conduct observation or we do an experiment, sometimes we have a tendency to make errors, like in terms of reading or writing down information. Now, after you have placed your information in order, in some cases, you might look at your data that you have gathered, you should have followed a certain trend. But then all of a sudden you see a very, very low value that is not even close to some of those numbers, or something that is too high. So that will raise some eyebrow or ring a bell. So those extremely large and extremely small values can give rise to make your analysis not be that accurate, or can make your results completely inaccurate because they deviate from the mean. They are too large or either too small. Now, those type of values that are either too big or too small are known as erroneous values. So erroneous values are values that are either too big or too small. Now, here we will be calculating the trim mean. But calculating the trim mean, we also need to consider the arithmetic or the actual mean, the ratio of it. So in this case, we know then that when we find the mean, the ratio here will be 723 over 20. That's what we will be using. And this is the actual mean here, 36.15. But I only calculated because in some problems they might ask you find the mean and then find the trim mean. So I just use it like that there, but this will be the ratio that you will be actually be using. Now, in order for you to find the trim mean, the percentage will always be given. So you have here percentage trim mean, like 20% trim mean, a 30% trim mean, a 40% trim mean. So what we need to do, we're gonna use this formula. That percentage is out of 100. So whatever percentage you have or that they're asking you for will be placed over 100 times the number of observation. In this case, the number of observation, there are 20 observation. So if you want to find, in this case, we're asking to find a 20% mean. But before we do that, we find the actual mean, the ratio, which would have been 723 over divided by 20. Now, so our first step, after you have found the actual mean, your first step is to find the 20% trim mean, how many values that you will be trimming out. This is where you are using this formula to see how much value you will be trimming out from each end, from either end. So 20 over 100 times 20 will give us 4. So this is telling us, but remember the information, the data must be in order. So we need to cut off 4 values from either end of this set of observation. So if you notice coming from the front, we cut out the first 4 values, we remove 11, 12, 13, and 16. And then at the end, we remove 54, 58, 68, and 80. So we have removed 4 data or 4 number or 4 observation from either end. Now, some people would have liked to say, but it's easier, so we don't have to use a formula. All I need to do is just simply adopt the one that I'm in black, count the amount that we have, which would have been 12 numbers, and whatever sum you divide by 12, that will give you your trim mean. It's correct, yes, but I want to see working and how the formulas are being used. So this is what will happen now. After you have identified how much numbers you're gonna be trimming from either end, or then you go and you do that. You could either use a slash down here and another slash to separate them. And then what you do, if you notice for the trim mean x bar t, 723 minus, because remember we are removing these values, so the sum will no longer count. So when we add 11, 12, 13, and 16, we will get 52. And then when we add 54, 58, 68, and 80, we get 260. Those are the values that we are removing. So we add them together, 52 plus 260, that will give us 312. So that will be 723 minus 312. And then this will be 20 minus 8. Why 8? Because these are the amount of numbers we have removed, 4 from here and 4 from here. That's a total of 8. So 20 minus 8 will be 12, which means then that only these 12 numbers will be used to find the trim mean, the one in black. Having done that, xt will be equals to, because you could do this in a calculator, 723 minus 312, whatever value you get, to divide that by 12, and then the trim mean will be 34.25. Now, in some problem, they will be asking you, was it wise enough to use the trim mean, or why is it that the actual mean is different from the trim mean, and how would you account for the difference of the trim mean from the actual mean? Now, in this case, we do not see a wide deviation, 36.15 from 34. No. If you would have obtained, let's say, this value here, and here you obtain like 30 or 31 point, that's actually deviate far away from the actual mean. So what happened is that probably due to some erroneous values, and you need to identify which would have been those that causes the actual mean not to be that accurate, and we would have preferred the true mean rather than the actual mean. So that is how we find the true mean. First of all, you have to see the number of values that you're gonna be cutting out by taking the percentage that they ask you over 100 times the number of observation. In this case, you notice it was 4. We trim out 4 values from either end, and then we go to the actual mean, the ratio, and we add the 4 numbers that we have cut off from the left-hand side, and we also add the numbers that we cut off on the right-hand side. If you do not really want to do it in 2 separate ways, but it's easier, all you could do was to just simply add all of these, add all 8 of these, and that would have given you the 312. Then you don't need to have had this. That's the 723 minus 312, because then you will add the 8 values already. But I try to do things in a way that will make things much easier and much more flexible for you to use. Now the other point here is to find percentile. Remember now, we have spoke about the lower, the median, and the upper quartile. Now this is the percentile. Now the percentile formula is similar to that, because this can be used to find the 25 as well, and the 50% and the 75. Because if I plug in 25 in the percentage formula there, I would get 25 over 100, which is 1/4. If I plug in 50, half, and so on. So, however, if you notice, we do not call it quartiles, we call it percentile. So the P% representing percentile, you will be using that percentile given, because you will be also provided with the percentage over 100, and n you're gonna be having n. If you notice, the formula is the same, only because this is what regulates the percentage here per percentile. So if they ask you to find the 68th percentile for that set of observation that we have for those 20 set of observation, then P60 is equal to 60 over 100 in bracket 20 plus 1. We do the same calculation similar, so that will be the 12.6 value, which means then that we're going to be taking the 12 and the 13 value and divide it by 2. So we go here, we're going to be taking the 12. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the other value after that, 41. So 39 plus 41, and we divide that by 2. And then that will give you our 68th percentile. So this is another example. Okay, so that will be 39 plus 41 divided by 2. That will give you 40. So the 60th percentile will be 40. Here, this is a different problem. So let's see how it goes. And it's raw data as well. This is the last one that I'll be discussing. In this case, once again, the raw data has to be in order of ascending size. And they want you to find the mean, the actual mean. So the actual mean would have been 12.5. But the ratio here would have been 127 over 11, which we're going to be using for the true mean. Now they want us to find a 10% true mean. So that 10 over 100 times the number of observations, you will get 1.1. However, when you have situation, you round it off to the nearest whole number. So we're gonna leave it as 1, meaning then that we're gonna be cutting off 1 from either end. Let's say this was 1.5 or 1.6, then we would have rounded off to 2, whereby we're gonna be cutting off 2 values from either end. Everybody's getting the picture? Remember, we do rounding off in the per summer to the nearest 10, to the nearest whatever significant figures and those things. So when we round this off to the nearest whole number, this would have been 1 because you will have obtained 1.1. Do you agree? Hello? Hello?
Yes, sir.
Yes, sir.
Okay, good. So once again, we take the 137 minus the 4 is this 4 that we have here, only that 4. So it's 4. Only this 25 at this end, so plus 25. That will give us 29. 137 minus 29 divided by 9. Why 9? Because since we have removed one value here at this end and 1, so we have removed 2 values from the set of 11 numbers. So that will be 11 minus 2, which will give you 9. And then from there, we calculate our true mean. And once again, if you notice, our true mean is not too far, too bad from the actual mean, because the true mean is 12 and the other one is 12.5, which is the actual mean. Now, let's say that they ask you to find the 40th percentile. And the 40th percentile will be 4 P40, 40 over 100, 11 plus 1, the same thing here. Then that will be the 4.88 value. So we're going to be taking the 4th value, which was 6 in the observation, and the 0.8 fall into the 8. So which will be the 5th value. So we're going to take the 4th and 5th value, 6 plus 8 divided by 2, which gives us 70. I mean 7, sorry. Which gives us 7. Any questions?
No, sir.
Okay.
No, sir.
Okay, well, since there is no question, we're gonna hay preguntas. We're gonna end here today. Have a nice day. We are gonna be meeting you tomorrow as well, right? I will be meeting you tomorrow, right?
Yes, sir.
Yeah, and then we're gonna be looking at percentile and true mean for group data. Okay.
Okay,
Take
sir.
care.
Bye.
Bye.